Hello everyone. Today we will be continuing with the point that we left in the last lecture, that is types of feedback connection. In the previous lecture we have studied two types of connectivity, that is voltage series feedback connection and voltage shunt feedback connection. Now we will be studying about current series feedback connection and current shunt feedback connection. So let's begin with the first one, that is current series feedback connection. Okay. Now, the definition for the current series feedback, or what is current series feedback, can be understood through that a fraction of output voltage is been applied serially to the input voltage. So we call it as a current series feedback. Okay, there is a difference between these two feedback connectivity. One is series and one is shunt. That its application, how the output is applied to the input, in which manner it is applied, it is going to define that particular connectivity. Now here in this case we can see it is named as current series feedback. So obviously here the output part or certain part of the output will be connected to or will be given applied to the input voltage in the series manner or in the serial manner, and also we call it as a series feed series feed feedback. Okay, so this is the explanation or particular definition for the current series feedback, that certain part of the output will be applied to the input in a serial manner through the feedback circuit. Okay, the next one is the next point is, here we'll be seeing the block diagram of the current. Now here this is the block diagram of our current series feedback connectivity. Here the block diagram represents the two parts, that is a basic amplifier with gain A, and then there is a feedback circuit. We will denote this feedback circuit as beta. If you have studied or gone through the previous lecture, you will understand that we always denote feedback circuit with beta. Now here you can see that how the connectivity is done. The feedback circuit is placed here in series with the output and also with the input. Means it is going to be in series with the output and also with the input. So that is the reason we call it as a series driven shunt feedback. So it is named as current series feedback connection because it is placed serially with the output and also with the input. Now in this case, what kind of input impedance and output impedance we will get is both will be increased. Why? Because it is connected series to output as well as to input. We get a output impedance and input impedance increased. If you go back to the previous lecture when we studied about voltage series feedback, that time what we studied, as there was decrease in the output impedance because it was only connected in series to the input, but the output impedance was decreased that at that time. Now here you can see it is in series with both input as well as output. The feedback circuit is placed in series with output also and input also. You're going to get the input impedance increased as well as output impedance increased. Okay, this is the difference, straight difference between this current to voltage, voltage series feedback and current series feedback. So here the result is output as well as input impedance will be increased in this case. Next we will move towards how its circuit diagrams look. Circuit diagram looks like, because this is actually I have written circuit diagram, but it is usually the block diagram of the particular connectivity. Now this is the circuit diagram for the current series feedback connectivity. Okay, here you can see how the transistors are placed, how the resistors are placed, and on the left hand side the input of voltage is applied, and the right hand side we are going to get the output. Okay, then you on the right hand side image you can see that the same way how we derived few equations or how we stated few equations for the voltage series feedback, voltage shunt feedback, similar way we are going to have some equations for finding out few measurements in the current series feedback also. Here you can see that is Ri dash and R naught dash. Actually I have not put Ri dash here by mistake. Now you can note down this point, first one equation, as Ri dash. That will be equal to 1 plus beta into voltage gain into Ri. That is just the same as the uh, voltage series feedback. Okay, this is Ri dash. Okay, not only Ri. In the equal to part of this equation, that last one is just Ri. Now the difference between Ri dash and Ri, or R naught dash and R naught, is that if we put a dash on the top of the particular measurement or quantity, that time it is defining that input resistance or output resistance. Ri stands for input resistance, R naught stands for output resistance. If we put dash, that means it is with feedback, and if there is no dash into it, that means it is without feedback. So this is the first one equation for uh, input resistance with feedback. Now R naught dash is nothing but input resistance, output resistance without with feedback, sorry. Okay, this is the equation. These two equations are identical to each other almost. Now here what we find is voltage, beta factor is our important point over here. Now beta factor we find here is minus Re upon RL. That will be equal to minus 1. That is just same as the voltage series feedback. Now next shall move towards the uh, last one connectivity, that is current shunt feedback. We'll be studying about the current shunt feedback. Now what is current shunt feedback? It is just exactly opposite to the current series feedback connection. Now here how the current shunt feedback will be defined? It will be defined as the fraction of the output voltage will be applied parallelly to the input voltage. So that is the reason we call it as a current shunt feedback. In current series, we used to apply it to the input and output serially. Now here it will be output voltage will be applied, out certain part or the fraction of the output voltage will be applied in parallel to the input voltage through the feedback circuit. So we also call it as series driven shunt feedback. Okay. Now this is the block diagram of this current shunt feedback. Now here in this placement of this particular feedback connection, you can see that the feedback circuit is placed serially to the output, but it is parallel to the input. Okay, it is placed serial to output. Just pay attention to what I am saying. It is placed serially to the output, but it is placed parallelly with the input. That is the reason we call it as current shunt feedback. Shunt is the word that is used for the purpose of mentioning something that is parallelly placed. Okay, now as this feedback circuit is connected in series with the output impedance will be increased because of its parallel connection with the input. Okay, and the input impedance will be decreased here. Okay, whatever that is connected in a parallel connection, that impedance will be increased always. Now it is connected parallel to the out sorry as it is connected serially to the output, it will be having the increased impedance of that particular part, whether it is output or input. Now here you can see the feedback circuit is connected in series with the output, so the output impedance is increased, but it is connected in parallel to the input, so the input impedance is decreased. Okay, I hope you understood what I'm trying to say. Whatever that is connected means that particular feedback circuit is connected. If it is connected to the output in the serial manner, the output impedance will be increased. If that particular thing is connected in parallel format or parallel way, that part's impedance will be decreased. So as here you can see the output impedance is increased, whereas input impedance is decreased, because to the output it is connected in serial format, to the input it is connected in parallel format. Okay, next, now here you can see the circuit diagram of the particular current shunt feedback. In this you can see how the transistors are placed and how the resistors are placed, how the input and output is derived. Now there are a few derived standard equations which are already derived. We can just note it down the same way. Ri dash, that is nothing but input resistance with feedback, it is, which is equal to Ri upon 1 plus beta into Av. So Ri is nothing but input resistance. This is without feedback. Then R naught. This is R naught dash. Okay, it is nothing but 1 plus beta AB bracket complete multiplied by R naught, and the beta factor here is, it is positive, that is RE upon RF. So this is all about the connectivities that we have seen so far into this chapter. The first one we studied was voltage series feedback connection, then voltage shunt feedback connection, then we studied current series feedback connection and current shunt feedback connection. Now altogether all these four feedbacks, we will have them as a comparison into it. So we will look forward to it as a comparison, and we will have a comparison chart for this. So we'll see how the comparison chart looks like, or what are the differences between these four types of connectivities. Now see, this is a tabular format that represents how the different connections are different and how similar to each other. Like similarities and differences both will be reflected into this chart. Now the characteristics that we are going to see here is voltage gain, we will see bandwidth, then we will see input resistance, output resistance, and how the harmonic distortion, whether it is decreased or increased, and then noise factor. Now here you will see voltage gain. If we go for voltage series, it is decreased. Same, it is decreased for the shunt connectivity of feedback through voltage, and then current series connectivity we are having, same, it is decreased. Current shunt also it is decreased, means it is a kind of a similarity between all these connectivities for the factor of voltage gain. Second one characteristics is bandwidth. Now the bandwidth is also increased for all the types of connectivities. Then input resistance, we have already seen while studying the connectivities individually, that in which factor the input resistance is increased and in which factor the output resistance is increased or decreased. So here you can see in this voltage series it is increased input resistance, also in the current series it is increased, but in voltage shunt and current shunt it is decreased. Now about volt output resistance, for both voltage connectivities, voltage series and voltage shunt, the output resistance is low, it is decreased. Then in series, current series and current shunt, it is increased. Now the harmonic distortion is decreased for all the four connectivities, and the noise factor is the prime factor why we need the feedback, is that we want to eliminate the noise. So it is completely decreased into these all types of four types of connectivities of feedbacks. Okay. So here we have almost covered all these points. So we have completed with this chapter, that is feedback amplifiers. Okay, so thank you for watching the video.